YouTube. So, picking back up where we left off, this is just showing the one power conditioner with all the things plugged into it, and its own breaker. And so I know that I'm not going to trip the breaker that's on the power conditioner, right? Now, the power conditioner plugs into this thing. That is a symbol for like a quad box or a fourplex, right? So we have these. You see these all over in theater. These little boxes that have four plugs in them. Okay, so that's what that symbol is. And then that connects to this symbol, which is like it's used for like just special connector, which just happens to be like a twist lock something or other on the wall that we use so it would lock and not fall out of the wall. But then after that, it hooks up to a breaker somewhere in a panel. And that panel is, so you've got breaker panel 64 pp. And so that's an actual panel on a wall somewhere. You can open it up and there's breakers on it. It's got a label on it, panel 64 pp. And I've put in parentheses here, stage left deck. So you will find this stage left on the deck somewhere. You will find this breaker panel. Yes?
This is just a general question. How
Yeah.
do you know how much the interface and the consoles are using?
Good question. So there's a couple ways that you can figure that out. Sometimes the manufacturer specifications will tell you that. Sometimes the specifications will tell you power that it draws. It'll say like it's 100 watts or something. And you could, using math, figure out how many amps that is, because watts equals volts times amps. So if you know you have 120 volts, because that's what comes out of our walls in our country, and it says 500 watts, then you would be able to do, what would
4.
What would the amps be? If
1667, I think.
So if we solve for A, if watts equals voltage times amperage, and we have watts, it says it's 500 watts and 120 volts times amps. How would I solve for A on there?
Divide 500 by 120 to get 4.1667.
So it would be, amps would be equal watts divided by 120, right? Or actually, sorry, let me do this right. Amps would equal watts divided by volts. Is that right?
Yes, it is right.
Okay, good. So
that's why I keep looking at it.
Yeah.
I'm like, how did you do that in your head so quick?
So amps equals watt. Some people do. I'm not very good at doing this stuff in my head, but
I have to write it.
I can't either. I have to write it out. So yes, amps in this case would equal 500 divided by 120, which would be what?
4.1667, or 4.16 repeating.
Yeah. So 4.167 amps. Okay. So that you can figure it out. So if they tell you the watts, then you can figure it out, right? That's one way of doing it. There's another way. Sometimes, again, the spec sheet will tell you, sometimes you just look on the back of equipment and right next to the power connector, it'll say, what's going on there. Like it'll say this many watts or this many amps or whatever. And if all else fails, we have these little things called the kilowatt, which is a little box you plug into the wall, and then you plug your thing into that, and it's got a little meter on it, and you can say, show me amps, show me watts, show me whatever. And it'll tell you exactly how many amps are coming through this thing right now. Generally speaking, most electronic equipment draws more amps or more current when you switch it on than it does when it is in operating mode. Okay, so it sort of does this big suck. It's called the inrush current when it engages all the electrical circuits, and then it kind of settles down and it's good to go. So you want to prepare for that inrush current, not the operating current.
That's why when some people turn things on, they'll just immediately get back off. Okay.
Yeah, and so in that scenario, like maybe once you get into operating mode and everything's settled, it's fine. But if you switch it all on at the same time, it'll trip the breaker. So what you can do is you sequence it. That's why sometimes you'll see power sequencers in sound systems, where you hit a button and it goes click, and then it waits a second, and click, turns the next thing on, click, turns the next thing on. It's trying to keep you from turning everything on at one time. As long as you only turn on one at a time and let that settle, and then turn the next one and let that settle, then you can have all of them on the same circuit and you're fine. Okay? Power amplifiers are notorious for having this huge inrush current. But a lot of manufacturers these days have built-in sort of throttling circuits to slow that down, right? So the amplifier takes longer to get to the point where it can do the job, but that's because they have slowed down that inrush current. So instead of sucking it all right away and instantly, so the amplifier is ready to go the second you switch it on and it kind of goes, all right, let's get ready to make some sound. And it starts slowly coming in. And you have to count to 5, and now the amp's ready. Okay. and in that case, you can turn them all on at one time, and they'll slowly just kind of like, let's get it, so you just got to be careful there. Newer amps do that. Like D&B amps do that. L Acoustics amps do that. Yes.
So that thing in the wall right there, that's a 4-plex?
Yeah, that would be a 4-plex. Yeah. So this is a breaker panel, and I've just labeled it so I know where it is. And in that breaker panel, there are 2 breakers that I'm using. There are more than that. Okay. You don't need to necessarily map the entire electrical system for the entire building. You just need to make sure that that the parts that you are using responsibly. And that way, if like there's a breaker up here that feeds panel 64 pp, and it is a 150 amp breaker. If that thing trips, a lot of people are going to start asking questions. Okay, how did that trip? And I'm going to say, well, I'm drawing 22.5 amps off of it. What are you drawing off of it? What are you drawing off of it? And somebody will say, oh, well, I'm drawing 100 amps off of it. Or in most cases, because we're the only ones that do power diagrams, none of the other departments do. But we'll always know, and so we will say, well, I don't know. It's a 150 amp breaker. I'm drawing 23 amps off it, so it can't be me that's breaking it, right? And then everyone else has to figure out where the other 125 amps is coming from. Okay. So you just have to plot the stuff you're doing so that you know that you're not the one breaking something. Okay? But in this panel, I've got breaker 16 and breaker 15. And on breaker 15, it's a 20 amp breaker. I'm drawing 12.5 amps off of it. Breaker 16 is a 20 amp breaker, and I'm only drawing 9.9 amps off of it. So both are fine. We're good to go. So over here, this is just a regular surge protector. Just a plug strip, like, the one on the floor right there. Okay? But guess what? Those have breakers in them. Those have little buttons that pop. Yeah. So those are surge protectors, and they usually don't actually protect from surges, but they do have a breaker to, if you pull too much current, they will trip that. And notice how the breaker on the surge protector is 15 amps, but the breaker on the panel is 20. So this will trip before that trips. And the idea there is you could have, usually with a circuit that's in a panel, there will be multiple receptacles on a wall that are fed from that breaker. But if you have the surge protectors on every one of those, then if any one of those branches exceeds 15 amps, it takes the whole thing down just to protect you. Okay?
So what happens if your first level of amperage goes over 20? Will it affect the 20 amps max?
Like if all of this goes over 20?
Yes.
Well, presumably this would trip first.
Would it trip the other one?
No. If this breaker does its job, it'll trip before this one has a chance to. Okay? And that's, again, to keep this from shutting down everything else that's plugged off that circuit. Right? Because you could have 3 surge protectors on that circuit, because there could be 3 different receptacles around the room that all feed off that circuit. And so if the breaker on the surge protector has a smaller braking capacity than the breaker in the panel, then presumably that will trip before the one in the wall trips, and shuts the whole room down, right? That's what you want. And that you always want, the further you go down in this, you want your breakers to be smaller. Like I would never want my surge protector to have a 20 amp breaking capacity, but my panel to have a 15 amp. Because then I could be doing something here, and the breaker here would not trip, but the one up here would, and it would take out everybody else. Right? So you don't want that. And that goes into like this big one here, so that 150 amp one. What I wouldn't want is for this to be 175 amps. Because then I could potentially pull 151 amps, not break this, but I could shut the whole building down by doing that. Everybody else that feeds off that too. So you always want, as you go down and down, closer and closer to the things that plug into the wall, each breaker should get smaller in its capacity. That's an electrical code thing. Okay. This is a special thing. This is a sequencer. So remember that the thing I told you where you sequence it on and off? So here we have the sequencer has 6 20 amp circuits built into it, okay? And they are attached to, in pairs, to 40 amp breakers, which should be fine, right? The sequencer will, and you don't have to diagram this, but the sequencer will do A, B, C, and then D, E, F. Keeping in mind that theoretically, you could have 20 and 20 here, and that would match the 40 there on that breaker, and that's fine. But what you don't want is if I switch both of these on at the same time, and you have inrush current, we could potentially exceed it. Okay, so that probably wouldn't happen if this really is 40 amps and these really are 20. It shouldn't happen, but just in case. Sometimes the breakers aren't very fast. So remember, the breaker is just there to stop, to cut the power before the building burns down. And so sometimes the breakers aren't instant, right? They'll let it go for a second. Like you could go past 40 amps for a little bit, but it's like, oh, if this goes on for more than a second or two, I'm shutting it off, right? So anyway, so that's what's going on here, is I'm just sort of showing what I've plugged in to each leg of this thing. So B is 20 amps, and I'm only pulling 17 off of it, so on and so forth. Now these branch circuits on the sequencer have switches on them, and they have individual breakers. And then this line here, this dotted line, that represents that these breakers are all linked together. Sometimes that means there's like a little bit of plastic that's like clipped onto all three of them, which means if one trips, they all trip. Okay? So if any one side of this goes down, it takes down the whole thing. And that's on purpose. Because if somehow you're on this part of it, you're exceeding 40 amps, something is very wrong. And it's probably something wrong with this sequencer. And so you want the whole thing to shut down. Because if somehow you're able to exceed 40 amps here, you should not be able to do that. Right? Because it's 20 and 20. Which means you should not be able to exceed 40 amps on that leg. So if you do, something is definitely wrong with this sequencer, and you want to shut the whole thing down. So you tie those three breakers together, which means one goes down, they all go down, because of how it's fed. That make sense? What's that? It is a lot. Yeah, it's quite a lot. And then here's another sequencer. Okay, with another set of breakers. Okay, and that feeds another breaker up here.
Could you go back to the virtual one?
Oops, what did I do?
Yeah, to what was
So here's your second one, right?
Yeah. Oh, I just thought some of the calculations were off. I thought I saw 16 amps used and 14.5.
Oh, no, I don't think so.
No.
That would not work. that would not work.
16,
Right.
14. Oh, that would be 30.5.
Is there a, where are you seeing?
Oh, on thrust track 3. And then to the area to the right of it.
Here?
Yeah, I thought I saw 16 amps.
Oh,
here.
no, it's 10 amps here, 10 amps, 20 amps. 14.5, 10.5, 24.5 against 40.
30.5 would work.
If that was somehow 30.5?
Yeah.
Yeah, that'd be fine. Okay, so you get the gist of this here. One thing I want you to notice is you see how the lines that carry electricity are thicker than everything else? That's on purpose. Okay, I'm going to introduce you to the concept of line weights today.
Oh my god,
Okay.
writing kids complain about this so much when they take hand drafting.
Yeah. Line weights, pain in the butt.
Yeah.
So here's what you're going to do. You're going to start by you're going to add these symbols to your template. Okay, they're not complicated. You should be able to draw these. They're not that bad. Let me, let's see. Here we go. So here they are. Here's what they look like. Okay, you see? No big whoop. None of them are too tricky. I will show you how to do this little arc if you want. So the command is ellipse, I think.
Wait, those aren't circles?
No, I do it as arc. So you're going to go click, click, and then set it to whatever the angle you want is. Okay, that looks good. And then you're going to trim it here and there. Oops. And then you're going to just move that. You're going to say, all right, take that and wah, wah. So you can use arc. You can also use ellipse and trim as well, whichever one you want. I like arc. Everything else is just circles and lines. But you can do the whole power diagram using only these symbols. Okay, so you draw these symbols first, add them to your template, and then I want you to make that diagram that's in the example. So it's just, you just make copies of all those devices, put the labeling in, connect them all up. Okay, now let me show you this line weight deal. So if we, where is it? Okay, so look in my layers here. This column is line weights. And all of them say default except for my sound connection and my sound equipment. The sound connection is the pink color, which is going to be all my electrical lines. And then I also have the box, the green stuff, is also thicker. So I've set that to a very specific line weight, 0.35 millimeters, which will be a little bit thicker. Now, if you look at, if you go to your formatting and look at, is it? No, it's not line types. I think it's here. Somewhere in here it might be in preferences. No, I don't remember. Where is the default line weight? Why am I forgetting this? Oh, here, line weight. Format line weight. It was right there the whole time. So I was like, I thought that was a line weight settings. So default is 25 millimeters, which means if you just say default, it's going to be 25 millimeters, and that's AutoCAD default. And so I just have said on a couple of layers, I want to be a little bit thicker than that, 35.35 millimeters, and then all that stuff will be a little bit thicker. Now watch what happens. You can actually turn on line weight display in model space. So there's this little button down here that we have yet to turn on, which is show hide line weights. And it'll show you those things thicker. You see that?
Oh. We don't need them thicker, do we?
I want you to do them thicker. Now, you don't need to display that in model space, because sometimes that can be annoying in model space. But what happens is then in paper space, when you plot it, it will plot that stuff with those line weights.
So it's okay to change the line weight on, like our layers like that. We don't have to make new layers specifically for the power diagram.
That's up to you.
Okay.
If you think that that would work for you for even your system diagram stuff, then go for it. But if you want to have separate layers for the power just to do that, then go for it.
I'm just wondering, like, is it going to affect heavily, like, our template that we already have? Like, if we're affecting a layer for everything,
Yeah.
is that going to look weird?
So it shouldn't. You know, the nice thing about line weights is it helps with the visual cohesion of everything. So it helps you to tell the difference between different things, which can really help when you're plotting stuff. If some lines are thicker than other lines, it helps you know that those lines are more important, or helps frame things, or it helps draw attention to something, right? So that's what's happening in my example. If we actually look at this thing again, you notice even when I zoom out of this thing, you can see that some lines are thicker than other lines, right? That's the point, is it helps with that zoom out test. You generally speaking, you want to go light on the line weights for text, because when you zoom out on text, when it has a thick line weight, it blurs. But the lines like this, like having those thicker, really helps, right? It helps this drawing look a little bit better, and it helps it with that zoom out test. Okay, so play around with that a little bit and see if I even go in here. If I really zoom in, it's less pronounced when you zoom in. I mean, these are thicker than that text, but it's less noticeable at this scale. But when you go out, that's when it starts to make sense. Like, oh, okay, yes. Make sense?
Yeah. Okay, so you would want us to do this, so let me try it.
I do want you to do it. What I'm saying you can decide is if you, some people like to see the line weights in model space, some people do not. Because the thing that I found is in model space, the line weights are exaggerated. So it makes you think it's thicker than it really is going to be. But it just helps you remember what's thicker and what's not if you turn on you toggle that in model space. But it'll always plot in paper space, so you're good to go. So your assignment is you'll add these symbols to your CAD template. And then you will use those symbols to replicate the power diagram that I've shown you in Canvas. By the way, did your picture show up in Chrome? The images show up in Chrome for you?
Yes, it did.
Excellent. Okay. And I've said pay particular attention to line weights in order to emphasize the power signal and not the box, not the breaker boxes and all that kind of stuff. You should turn in a revised DWT file. So I want a new template file now that has these symbols added to it with everything else that you've already added to your template. Okay. And I want a DWG file containing your power diagram that you drew. Make sense? That's it. Questions?
Oh, so an issue I had making the template last time was those things in it, and I scaled it horrendously. It was so large, and then I had to figure out how to get it to the correct size because I want to use yours for reference because I know it's accurate. So what can I do to know what size is too large and too small?
Like for the symbols themselves?
Yeah, but just like the.
I mean, you can see here's my stuff in there. You can see kind of approximately how it scales. You just want to be consistent. I mean, it doesn't. These symbols are not to scale. They don't represent anything real. It doesn't really matter how big they are, because AutoCAD you can just zoom into the page layout however you want. What you want to be careful of is that you are being consistent in your proportions. That's where, if you draw the loudspeakers significantly larger than the amplifiers, then that will become a problem when you start laying all this out. So it's really just about proportion more than anything else, than actual size. They can be whatever size you want. Just make sure they make sense proportionally. Does that answer your question? Okay. Other questions?
So, yeah, we just go up there, we set a length for a thickness for our line.
Line weight.
And
Yep.
then
Yeah.
we just expand it, and what was the control to set a fixed length for thickness for the line?
Well, so the column is line weight. So there's this column called line weight, and it should say default on everything, and you can drop down and you can pick whatever line weight you want.
Okay.
I'm doing 0.35,
Okay, that makes sense.
right?
But I mean, is it going to affect all of the lines, including the loudspeaker ones?
Yes, it will affect everything on that layer, unless the object on that layer says, so for example, like if I click this object, I can say line weight under properties, and right now it says by layer, which means it will use the line weight definition for the layer. If I need to override that for some reason, I can go in and say specific line weight for that object. I would recommend against that, because part of the whole point of layers is that you can make a change and it applies to everything. So if you're worried about those things not wanting to both be thick, then just make new layers for the power symbols, right? And then apply the line weight to the layers, the new layers. It's up to you how you want to handle that. Other questions?
It's really cool, by the way,
What's cool?
the adjusting thickness.
Oh yeah, it's very cool. Yeah, this is some of that spit and polish stuff, that really sets really great paperwork apart from mediocre paperwork. Is attention to line weight. Seems like it's like such a minuscule thing, but boy, does it make it pop when you get it right, Because in the old days of drafting, what you would do with hand drive is the pencil. You would just, like, on the important stuff, you would drag the pencil over a couple of times to make that line thicker. But trying to do that consistently with a pencil is crazy. So when mechanical pencils became a thing, it was easier. You would have pencils with different thickness of lead in them for different sizes of lines you were drawing. I still have mine somewhere from the days when I learned how to hand draft. I have my 3 different pencils. I had a 0.5, a 0.7, and a 0.9. But anyway. All right, that's it. You can get to work now.
Do you think